The third part of today's presentation is the aspects of the design that need to be considered when designing any water-cooled system, correct? And those aspects are broken into these points. The space available, right? When designing any cooling tower system, in order to have an efficient system, these points need to be considered. The space around the cooling towers, the obstacles surrounding the cooling towers, what are the noise requirements in that specific facility and surrounding that building, the plume, taking into consideration the maintenance, the future maintenance of the cooling tower, of that specific cooling towers, and finally, types of cooling towers and their layout, arrangement, and noise sources, right? So the first point is the space available. The reason to have a space is that we need to avoid any kind of changing the inlet wet bulb to the cooling tower. The wet bulb from the discharge of the cooling tower is higher than the inlet wet bulb or the ambient wet bulb. So we need to avoid any kind of changing or interfering with the entering wet bulb temperature to the cooling tower, because as Jay explained, this is the major form or the major factor in our evaporation concept, correct? So ensure a proper space between the cooling tower will give you the assurance of a proper performance of that specific machine. The next point is the space and obstacles. It go back to the same reason. We need to avoid any type of recirculation, right? Any recirculation can affect the performance of the cooling tower. We need to always to have proper space and proper clearance around the cooling towers. And usually these kind of numbers or parameters or space required will be available in the selection sheet you are getting from the manufacturer. Now, in terms of noise, each cooling tower or every type of cooling tower will have different noise sources. I'll start with the cross-flow type. The size of the arrow represent the higher noise. So the big arrow represent the higher or the louder noise source of the cooling tower. In the cross-flow, the highest noise source is the discharge of the fan. All right. And the second to that will be the air inlet sides. And the third quietest part of the cooling tower is this side, which we call the case faced outlet or side, sorry, case face side. All right. And in the counterflow, this will be different. The counterflow will have 4 inlets, 4 directions, and the heaviest part or the loudest part is coming from the basin, the falling water noise. After that, there will be the mechanical or the discharge side of the cooling tower. And finally, the 4 sides of the cooling tower, the case face sides. All right. These are the major noise sources of any cooling towers. Now, all right, this is, sorry for that. Now, when we consider or when we take into consideration the cooling tower noise, the most important factors that we need to consider is where the people will be hearing it, right? And this can vary with every location. What's near that cooling tower? What's near that facility with the cooling tower? Hence, we have the near field consideration, which is surrounding that cooling towers. There is a common areas, there is a pool, gym, ballroom, etc. What surrounds that cooling tower? And the next consideration will be the far field. What's surrounding that building? Is there is a hospitals, there is a balconies, is there is any type of facility that can be disturbed with the cooling tower noise? These are the very important points, right? So now when we want to design or we want to have a strategy about the sound and the noise data, the most important point is to understand the project specific requirement, right? Is there is a noise sensitive areas in that building or surrounding that building? And what are the flexibility that we have in terms, for example, for reorienting the cooling tower? Of course, this is only applicable in the cross flow because it has the 2 sides only. So reorienting the tower in different direction can push the noise away from that specific direction facing the air inlet side, right? And finally, Is there any noise sensitive time of the day? This will help us also and help you as an end user or as a designer to reduce the noise. For example, at night, running the cooling tower or running the fan at 50% of its speed will help you to decrease almost 12 dBA, which is a big number. And running the fan at 66% of its speed will give you almost 8 dBs. These numbers and knowing these kind of informations will help you to have a smooth operation of the cooling towers and to overcome any potential noise issue you might have. Right? Of course, noise can be treated, and there are multiple treatments methods. First of all, which we just mentioned, the reorientation of the tower. Right? Again, this is applicable for the cross flow. If you have any noise sensitive area facing the air inlet side, reorienting the tower can solve this problem. Second is lowering the air inlet height. Usually this is only applicable for the field erected type of cooling towers. Third one, splash attenuation mats. This is only applicable for the counterflow. It will reduce the noise of the falling water. We will install it between the fills and the cold water basin. And then the variable speed gearbox, which will help us to reduce the fan speed, which will reduce the noise. And not finally, and then having barriers or louvers around the cooling tower will also break the noise and help you to reduce it. Other option is that using a low noise fan. Usually in the cooling towers, we have multiple type of fans, the standard fan, low noise fan, and there's the third type, which I'm going to cover it in a bit. So using a low noise fan also can help you in reducing the noise level of that cooling towers. Inlet outlet attenuators. This, whenever you are going to use this solution, you need to consult your cooling tower supplier. Inlet outlet attenuators can create a static pressure, can change the airflow, or can create a pressure on the discharge fan, which can disturb the operation of the cooling tower. So make sure you consult your cooling tower supplier before installing any inlet outlet attenuators. Finally, the ultra-quiet fan. There are different terminologies for the ultra-quiet fan, depend on the suppliers. We at SPX, we call it ultra-quiet fan. Some other manufacturers might call it super low noise fan. It does the same job, it's just a terminology. And this is the quietest fan that can be installed in a cooling tower. Right. Now, the plume, something not very common in the Middle East, rarely there, but you should be aware of it. The plume is basically this vapor that's coming out of the cooling tower, and these are two pictures for the same cooling tower before and after the treatment. Right. Now, the spacing around the cooling tower. Usually, this is also something that needs to be taken into consideration, and those numbers will be there in the selection sheet. Spaces that you need to have for the cooling tower in the cross flow type around the air inlet sides, right? And the maintenance access required. This number can vary depend on the size or the dimensions of the cooling towers. Usually, not a rule of thumb, but usually it's between 70 centimeters to 1 meter to allow you to have the maintenance access for any potential maintenance possible, fills, replacements, cleaning, etc. Have a proper space to enter the tower through the access door. So usually it varies from manufacturer to manufacturer and varies according to the dimension of that cooling tower. Now, for the counterflow, same spacing and clearance need to be considered, right? The differences is that in the counterflow, you need to have it from 4 directions since you have 4 air inlets, right? And the maintenance also access. You need to have a clearance and spaces around the cooling tower from 4 different directions because the fills are distributed evenly around the cooling towers, and you need to have that space for 2 reasons. First, airflow, and second, any potential inspection, replacement, maintenance for the internal components of that cooling towers, and also inspection for the mechanical parts, gearbox, motor, fan, etc.